Okay, let's introduce you to the basic test framework that does exist with Golang. So I've created here your classic intro programming 101 here. I've declared a type, which is a struct, and I talk about struct in another video. It's basically how you aggregate and make your own types in Golang. So I have a point, and a point, of course, has an X and a Y coordinate. We're sticking to just simple, what would that be? Simple graphic at this point, nothing fancy. So it's got an X and a Y point with, you can just imagine that the coordinate system, the top left is 0, 0, and the bottom right is your maximum values. Think about like laying out on a screen. I've got some getters and setters, and I just generated these in the IDE. I just went to, where is it? Generate, there we go. I said generate, well, getters and setters would be here if I hadn't already generated it. And I generate out of the getter, which in Golang, instead of a getX, which personally I prefer, but Golang simply declares the uppercase function name of the value to be the getter. That's by default. You can make this get if you wanted to, but by convention, this is how it is. I still use get a lot of times. And of course, set value for setting the value inside the structure. If I made these capital, they would be public, and I could set them without going through a getter and setter. But I chose not to on this example. So that's a point, and a circle has a center, which is a point, and it has a radius. And I've created a function called calc area that calculates the area of the circle and returns it as a float. Notice radius is type int, which is an integral value. The value of int is roughly defined as the normal integer type for the operating system. You could be specific and make it an int 32 and unsign it, etc. But we're just going to just do int and let it optimize for the compiler. And float is a floating point number that has more precision. There's the float 32 and float 64. It's just more precision, and I like precision. So basic thing. So I made a little test here. So if you see over here, example.go is this file I'm looking at right now. The test for this is example, well, it's actually example1.go. It's the name of the file, example1 underscore test. And like some things in Go that you would think would just not matter, naming matters. The IDEs, everything will see this as a test when it's labeled underscore test, and it has functions in there called test something. The name here is important because if I wrote a function called my shape test and did that, I can't run this. Go won't see it and Go won't run it because it doesn't see it as an entry point. If I name it test shape and take an argument of t, testing.t, t is a structure, and the test package that I've imported as testing, I imported the package. Testing.t is a well-known structure in that package. And if the function has a signature, uppercase test, and then what leaves object of what you're testing, which takes in a pointer to a testing.t variable, then this is considered a test and it will run it. So you can see I just basically create a new circle. This is one way you could do it by hand. Got the circle in parentheses. I initialize the member variables. Center is a point, I initialize that. Again, same way, creating a point, initializing its member variables. So this is a circle whose center is at the x coordinate of 1 and the y coordinate of 2, and it's got a radius of 4. So if you, pi is just a constant that I've already created up here, which is float 3.1415926536, if I remember my high school algebra correctly. And pi, or the expected area, is going to be the radius squared times pi. So pi times 4 times 4, if I remember my high school math correctly. So we'll call circle, we'll call the function on it calc area. Get the calculated area. And then we'll test manually to see if they match. I have another example down here. Hold on thought. So we'll just, it's that simple. Test see if they match. If not, log an error. If you can't go any further with that, you can log a fatal, which would stop this test from running. Error would just log the error and go on. If you log a fatal, it will stop this test from running. Is there success? No, there's not. Success is not logging anything. Okay, so let's run this test. Because I followed all the conventions, I can just right click on the IDE and say run. And let's see. Oh, well, look, I got the wrong results. I expected 50.26 blah blah, and I got 12.56 blah blah. I got an error. Okay, well, my math has never been very good. Let's go look at this. And yep, I can see it right here. I don't have this squared. There we go. Notice how I wrap this inside float 64. Take that off real fast. Because these values are declared as integers, or this value is declared as an integer, I'm going to get an error when I try to mix the operations of multiplying it here. So I'm just going to cast it to float 64. That makes it happy. I didn't have this problem here because I hadn't declared what 4 is, so it auto-promoted it. But on the other side, in the function, these things are most definitely declared as int. So it won't let you combine operations between a float 64 and an int. So you have to explicitly convert this value up to a float 64. Now let's see if it worked. Lo and behold, it worked. Now, you can always do this. You can always add your own if test. You can do what you want. Somebody created a clever little library called Testify that has asserts that kind of look like asserts in Java, asserts in Python to make Golang more friendly to people. So I could take this out, and I have identical functionality here, using this package, third-party package. We use this all the time on our code that has assert equals, expected value, and something to log if they don't match. And as you might imagine, there's asserting on equal, there's asserting if it's null, asserting if it's not null, asserting if it's greater than, less than, etc. So this is a handy package that we use a lot to make tests. And this is all you have to do to make Golang. In fact, if you run go test from the command line and give it a package name, it will recurse and run every single test in that package following the pattern. Does it have in an underscore test? Let's go inside of it, run everything that starts with tests that takes a pointer to a test. These are how tests are done in Golang, unit tests. You can do any sort of test you want with this pattern, but this is your typical unit test in Golang. Okay, I'm going to stop here. We'll talk next about some more fun stuff with Golang.